So to find the ninth term, go to your formula sheet. Does someone have their formula sheet with them? Does it say this part on your formula sheet? Or does it just have the TK plus 1? It just has the TK plus 1. So this part right here is something you would have to know what this is talking about. So this formula in blue says if I want to find term 9, that's telling me the K value is 8. I get the n from my exponent, but that's not told to you on your formula sheet. So you would have to know how to use this formula, where things come from. Okay? So I'm going to get 10 choose 8, this K is 8. A, doesn't tell you on the formula sheet, is always that first term. In this case, it's an x. And to the exponent of 10 minus 8. And B, the negative stays with that number, be negative 2. Go to your calculator or do it in your head. 10 choose 8. 10 choose 8 you could do in your head. See if you can figure it out. Don't say it out loud and let everybody get a chance to do that mental math. Okay, this is what I want you to imagine. Right, that's 10 choose 8. Expand the bigger one until that 8 factorial cancels out. Did you get 45? Mm-hmm. Right, because you go 10, 9, the 8 factorials would cancel out. And you just have 90 divided by 2, 45. Okay. Of course, these are almost always calculator questions because you will get very huge numbers. So you can do the 10 choose 8 on your calculator as well. Whatever scientific calculator you're planning on using for the exam, you should be using it for your reviews. You should be making sure that you know where these buttons are for your exam. Okay? And then this becomes x squared, and this becomes negative 2 to the 8, positive 256. And then we put this all together. $11,520. Okay, I'm going to get you to turn now to page, questions 5 and 11. I'm going to get you to turn either to page 734, which is blank, or 751. And we're going to look at what are binomial theorem questions that just increase the difficulty a little bit. And I've got sort of four things that have sometimes come up on exams. and I tried to list them here of the more difficult ones, from the easiest to the hardest. So I'm going to make up an example for each of these, and then we're going to work through it. So the easiest of the more difficult questions is finding the last term. So the question will be something like this. Example. Find the last term in 3x minus 5y to the 8. It's a little bit more difficult than the question we just did. The question we just did said, find term 9. Right? Told you exactly which one to find. This one you have to know how many terms there are in order to find the last one. How do we tell how many terms there are? That tells us. How many terms are there? 9. So there are 9 terms. So this question, we have to find term 9. And now it's an easy, just like example 3. As soon as you get it to the point where you can just plug everything into the formula for binomial theorem, that's really easy. And as far as plugging things into the formula, to avoid screwing up, okay, so I'm going to go to my formula. N is 8. Choose if I'm finding term 9k would also be 8. 3x to the 8 minus 8 and minus 5y to the 8. And when you're working through the formula, simplify each of these inside of brackets first. 8 choose 8 is 1. Anything to an exponent 0 is 1. And the minus 5y is going to be to the exponent of 8, so that's going to be positive. That's a big number, 5 to the power 8. Three nine zero six two five. Now, you could also have thought about Pascal's triangle, expanded all the way through. If you were finding the last term, does it make sense that in the last term from Pascal's triangle there would have been a 1? And then you would have just the second one 8 times. That should make sense using Pascal's triangle as well. So if you're asked for the last term, it's really not a very difficult question. Okay? Now, a little bit more difficult I'll use exactly the same question. Find the middle term. The number one mistake in this question is students find term 4. We already determined from this one that there was 9 terms. Right? If you write out the numbers 1 to 9, which one is in the middle? 4 to the left of 5, 4 to the right of 5. 5 will be the middle term. Okay? Does it make sense that they can only ask you middle term questions if you have an odd number of terms? Right? Because if you only had 4, which one is in the middle? Right? If I put up 5, you can see which one is in the middle. I can't show you because it's appropriate for class. So, and then at this point, I'm going to just do dot, 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 because at this point it's going to be easy. Once you know that it's term 5, you just plug it into the formula just like we did before. Do each thing separately and simplify them first, then multiply it and put it together. Okay? All right, so now we're going to get, of the difficult ones, the last term is the easiest. The middle term is just a tiny bit harder. The term containing and the constant term, these are the most difficult. So they look like this. Find the term containing x to the 9 in the expansion of, which one am I going to? 3x squared minus 2 over x to the exponent of 9. First of all, that exponent is 9. How many terms are there? 10. So option 1 for this question, which is the long way, and it will work, is you find all 10 of them. One of them has an x to the 9 once you finish simplifying. You circle that one, you've got the right answer. But this is very time consuming. Can you see finding all 10 would be very time consuming? You could do Pascal's triangle, but you would have to make Pascal's triangle until you had row 10. That would be a little time consuming. Okay? So what we do in these questions is, and I'm going to just write out our formula again. We're going to plug in everything that we know into our formula. Here's our formula. So, based on what we have, we do not know which term it is. So does it make sense that we do not know what k is? Do we know n? Yes, we know that n is 9. I still don't know what k is. Do I know a? Yes. It's going to be 3x squared. And it's going to be 9 minus k. And I know b is negative 2 over x. So technically, if we want to find the term containing x to the 9, the only thing we don't know is k. And the only hint that we're given is that it has an x to the 9. So the strategy for this one is to use the hint. And in using the hint, what we are going to do is temporarily, we're going to ignore all the coefficients, which are the numbers in front, to find k. Because we know that our answer is going to be, and I'm just going to write a space here, our answer for term 9 is going to have something x to the 9. But I'm just going to ignore the number in front. And I'm just going to say the only hint that they gave us dealt with the exponents of x. So on the right-hand side, if I ignore everything, that's going to be a number. Can you see that you can ignore the 9 choose k? That's just going to be a number. I'm going to ignore it from now. I'm going to ignore the 3. But here, I'm going to have an x squared. Actually, I'm going to simplify it right away. That x squared to the exponent of, I'm going to use my exponent laws. Do you see that that x squared to the 9 minus k would be x to the 18 minus 2k if those were multiplied together? That's your exponent law. So I'm going to have an 18 minus 2k in my numerator. And the reason I made a fraction, because can you see that in the second one you have x's in a denominator. If you ignored the negative 2, because it's just a number, and just thought about the x's and the exponents, can you see from the second bracket that you would have an x to the k? And that would be in your denominator. Some people like to just guess and check at this point. Some people guess and check it right from the beginning. Sometimes on the exam they do say you have to do it algebraically, so we have to show this work. So I'm going to just show you the algebraic way. What's your exponent law when you're dividing? Dividing with the same base, you subtract, right? So do you see this become 18 minus 3k? And then if you went back to your exponents and logs unit, this is where remember I did this, so, and I put the 3 dots. Like, if the bases are the same, the exponents would have to be equal. The 9 has to equal 18 minus 3k, and it's not very hard. I'll move the 3k to this side, the 9 to that side. So we did all of that work to find out that it's term 4, and you have to be careful in these questions. Okay? Sometimes they will say which term contains x to the 9. We would be done. It's term 4. We found it. Okay? This one says find the term containing x to the 9. We haven't found it yet. We know it's term 4. We still have to find out what term 4 is. So it'll be 9, choose 3. Our a value here was 3x squared to the 9 minus 3. Our b value was negative 2 over x to the 3. Again, simplify each of these in brackets first. So what is 9, choose 3? $84. Put that in brackets. The reason the brackets are very important is sometimes people forget the brackets and then they think they should add or subtract instead of multiply. 3 to the exponent of 6, 729. X squared to the exponent of 6, x to the 12. Negative 2 to the 3 will be negative 8, and x cubed. So I do my exponent rules first. Now I'm going to put my numbers together. So 729 times 84 times a negative 8. Negative 4, 8, 9, 8, 8, 8. And then look what happens. My x to the 12 in my numerator, x cubed in my denominator. Simplify, I get my x to the 9. That's what I was looking for. Okay? So in our questions that are more difficult, these are definitely the ones that are the most difficult. Because you have to, we scroll back up and look at it again. Okay? Find the term containing x to the 9. We take out our formula. We realize that we need to find k. Put everything in the formula. The only thing we don't know is k. The strategy for that is saying the hint they gave me was an x to the 9. The only hint they gave me was dealing with the x and an exponent. So I could ignore everything else. Okay? Sometimes in these questions, they're not as difficult as this one. You can actually just look at the formula and you'll see the answer right away. Because sometimes it might be, like I've seen ones where, let's say you've got 11 choose k, x squared to the 11 minus k, and you have 3y to the k. And they say you need one with y to the 8. You can tell me what k is right away. You don't have to do any math. Where's the only y? right there. It needs an exponent of 8. What do you think k has to be? 8. Okay? I'll give you another one you can do right away. It has an x to the 12. What's k? 5. Because the only way you would get an x to the 12 if this was a 6, right? And the only way 11 minus k would be 6 is if k was 5. So there are going to be some, you will just, once you write out the formula with everything you know, there are going to be some you can see what k is immediately. The ones that you won't be able to see what k is immediately is when there's x's in both of them, right? And so you have to take both into consideration. Then we have to do this algebra. Then once you've found k, now it becomes the easy question. Finding a specific term is just plugging into a formula. As long as you know what numbers go where, that's about as easy as math can get. Because you're not actually having to think very much when you plug things into a formula. Okay. The last and the most difficult question looks like this. Find the constant term in the expansion of, and for this one we'll do 5x cubed minus 2 over x to the 12. Okay. First, it's difficult because you have to know what this means. This is a language you were introduced into grade 9, and you realize you didn't always listen in grade 9. What is a constant term? Like if I gave you a polynomial in grade 9, and I said, what's the constant term? It's the 7. Okay? So sometimes we need that trigger of a question that we, like, oh, what did it look like in grade 9? The constant term is 7. What does that mean for us? There would be no x's. Technically, no x's is the same as x to an exponent of 0. And now this is identical to the question we just did right before this. Right before this, he said, find x to the 9 in the expansion. When it says find the constant term, it's like saying find x to the 0 in the expansion. But it was one extra step to know that this means x to the 0. If I put this on your test, and you put up your hand and say, what's a constant term? The first thing I'll say is, oh, do you remember in class when I said you might put up your hand during the test and say, what's a constant term? And then you're like, oh, yes, but I still don't remember. And then I'll tell you, well, on a test, all I can say then is find all 13 terms, simplify them, and maybe one jumps out at you. But what's that going to do? That's going to take a long time. It happens like all the time. Someone asked that question, I'm like, oh, I have to remind you that we did this in class. And it's on the video, you can watch it again. And that you have to find all 13 now, and hopefully one jumps out at you. But the shorter way, we need to, right? We put everything into our formula that we know, and what we don't know is k. Exponent is 12, choose k, and then a is 5x cubed, 12 minus k, and b is negative 2 over x to the k. just a reminder, to find the k, we use the hint. We know that our term has no x's. We can ignore all the things that involve coefficients. So the only thing that we're going to look at is the x's and the exponents. Do we have x's in both our denominator and numerators? Yes. In our denominator, we would have x to the 36 minus 3k. And in our denominator, we would just have x to the k. This doesn't look like one that is easy to just look at and say, oh, I know k is blah. K is 5. Okay? It isn't. Okay? But it's not easy to just look at it and say. In fact, one strategy that sometimes people do is they say, oh, I'll just guess one. K is 5. What would happen if k is 5? Do you see that this would be x to the 21? And the bottom would be x to the 5? Leaving you with x to the 16. Obviously, k has to be bigger than that to figure it out. And some people who like the guess and check method can usually find it in 1 or 2 guesses. Guess something random. It's wrong. 5 was wrong. I need way more on the bottom. Okay? What seems to be a good number that could go on the bottom as a result, and boom, you find it right away. But if we do it the algebraic way, right, my exponent laws, this will be 36 minus 4k if I subtract the k on the top. And then now you can probably see that k has to be 9. But you can do this part. So 0 would have to equal 36 minus 4k. Move the 4k over. Divide. This means we have to find term 10. And now we can work through 12, choose 9. 5x cubed, 12 minus 9. And negative 2 over x to the 9. Choose 9 is 220. 5 cubed is 125. X cubed cubed would be x to the 9. Negative 2 to the 9. Negative 512. X to the 9 will be x to the 9. And sure enough, look at, do you see that your x to the 9s would simplify and go away, giving us a constant term. 220 times 125 times negative 512. And it's not uncommon to get huge numbers for these kind of questions. So of the more difficult questions, finding the last term, finding the middle term, finding the constant term. Constant term is the hardest. Finding the term containing is like the second hardest. You can circle question number 9.